Halo, Assalamualaikum warahmatullahi wabarakatuh. Well, today I would like to continue our lecture for the topic of volume of solid revolution in Cartesian coordinate or in Cartesian coordinate but with cylindrical shell. Here in bahasa Indonesia it is called cara silinder. Today we want to find the formula of the cylindrical shell method for finding the volume of solid resolution in Cartesian coordinate. Actually, in the book of Sullivan and Miranda, there are 3 sections here, but today we want to discuss about the first section. We want to use the shell method to find the volume of the solid revolution formed by revolving the region surrounding the y-axis, but the integral with respect to x. Once again, the area is rotated with respect to y-axis, but the integral with respect to x. Here we have the illustration of the idea of the cylindrical shell. At home, usually we have a water pipes forming the cylindrical shell. The cylindrical shell is actually consisting of 2 cylinders. The outside of the cylinder with radius r, the big R, and the small r. So this is actually the illustration of the cylindrical shell by using pipelines. And we want to use the formula of the pipeline volumes to make the formula for the volume of solid revolution by using cylindrical shell. As we know from the calculus 1 that the volume of this pipe is actually the outside pipe, the outside cylindrical volume minus the inside cylindrical volume. Of course, the outside volume is 5 times r square times h. Here the h is the height of the pipes, and minus 3r square h, where the r is actually the smaller radius of the pipes. By using this formula, we can construct the formula of the solid revolution by using cylindrical shell. We want to manipulate that this volume can be written as the phi times r square minus, the big R square minus the small r square times 8. But here the r square minus r square small is equal to the big R, the capital R plus small r, times the big R minus small r times h. But here we can manipulate that the r plus r is equal to the r plus r divided by 2 times 2. So we have the 2 phi times r plus small r divided by 2 times r times the big R minus small r. Here actually the big R and small r, the big R plus small r divided by 2, actually here is the middle of the radius. If the r small r is here, the big R is here, the R plus small r divided by 2 is something here in between. So this is actually the average of the radius. So later on we would like to the volume by using this expression. And then by using this expression we can briefly write the V is equal to this one by this. The V is equal to phi times the average radius times the height h times the r minus r small r. In word we can say that the volume is actually 2 phi times the average of the radius time height and time thickness. I mean the thickness of the pipe. The thickness of the pipe is equal to the big R minus R small r. We want to use this in parentheses here in this box. We want to use to find the formula. So let's go to construct the formula. The shell method to find volume of solid formed by revolving a region about the y-axis, but the integrand with respect to x, not with respect to y. Once again, this method is actually the area is rotated surrounding the y-axis, but the integrand not with respect to y, but with respect to x. That is the idea. So the idea is as usual, just by using the partition of the interval a and b. Here, of course, as illustration, if we have this area, something like this area, and then we rotate surrounding the y-axis, then the solid revolution pictures become like this. But we want to count, or we want to calculate that the volume is not integrated with respect to y variable, but with respect to x. So that later on we have this formula. But how to find this formula? We start to make partition on interval AB, x1, x2, xi minus 1, xi, xn minus I, and b is equal to xn. So that after we have this partition, we assume that the delta x is equal everywhere. That means b minus a divided by n. That means the subinterval are equal. If you take the subinterval are equal, then the average of the xi minus 1 and xi is actually xi minus 1 plus xi divided by 2. This is called the ui. Actually, the ui is actually in the middle of the interval xi minus 1, xi. By using this formula before, by using this formula, the element volume become 2 phi ui, where ui is actually in the middle of the xi minus 1 and xi, times the height. The height fui. Actually fui replace for the height here. So we have the element of volume 2 phi ui f ui delta xi. That means from the formula, this one, 2 phi times the average of the pipes times the height and times the thickness. So it is exactly equal to 2 phi ui fx ui delta x.